3, the beginning part that what we did, I used FTC, which is the short term for the fundamental theorem of calculus. Good morning, Serena. How are you?
Good, how are you?
Good, thank you. So for the FTC or the fundamental theorem of calculus, we went over part 1 last time. Um, this part 1 is based on the area function. The a of x equals the integral from any beginning point A to the variable x. Oops. Okay. To the variable x, right, area function ax, which is a definite integral from a to xa is the real number, and the function as a function of the t is the dummy variable, and um, the t is the number between x and a, x and a. So anywhere, actually the other way around. So a less than or equal to x less than or equal to t. So with this definition that explain the area under the graph. This is a graph of the function f of t from the point A, and the x could be anywhere as long as x is greater than a. And then we find the derivative of this area function, which is the derivative of the definite integral from a to x of the function f of t with respect to t. We use a couple examples to show the relationship. So the derivative of the area or the a prime of x is the function f. Instead of the t dummy variable, we replace it with the x. Okay, so a prime of the x equals the function f of x. That means the derivative of the area is the function that provided. So by the fundamental theorem of calculus part 1, if you have, I'm going to bring it back to FTC part 1, that means when you find the derivative with respect to x of the definite integral from constant a to the variable x of the function f of t with respect to t, it is equal to the function f of x. So this is the main part of the FTC part 1. For the case that the part here is not just the variable x, but in the form of the function of the x. So I'm going to add another slide just to summarize what we did. And then we do more example. I mean, one more example at the end. So from the original part 1, which is d by dx integral from a to x, the f of t with respect to t equals f of x. Now, if you have the case that the integral from a to the function of the x, I use the term u is I use the notation g of the x as a function, and you find the derivative with respect to x. So this is original form. And then um, when you have this situation, so you're gonna use the chain rule together with the fundamental theorem of calculus part 1. That is, when you find the derivative of the function gx, g is the function. So you're gonna use chain rule by you treat this as the u. So that is the derivative with respect to u multiplied by derivative of u with respect to x. Okay, so I'm gonna treat this as the whatever the quantity that we have. So with the chain rule, if you recall, we identify the inner outer function. Okay, so then the notation d by dx, this part is represented by the derivative with respect to u or the function form that we have. So d by du of the quantity, which is this quantity, and then multiply by the derivative of the u with respect to x. And the quantity here is a definite integral from a to the u f of x, f of t dt. Sorry, this is t dt. Let's clean up, make it not too messy. So this is f of t dt. That means whatever the u here, you find the derivative and then multiply to the original form of the fundamental theorem of calculus part 1. And what you have to do next, take care of this part by replacing the t with the u, same as the original fundamental theorem of calculus part 1, that you replace the t with the x that comes there. But the additional part would be multiplying by the du dx on top of it. Okay, and the example that we did at the end of last session, I'm gonna go back to that problem. Yep, it's kind of all over the place, so I will redo that one more time. So this problem, we find, oops, screen is off. Okay. Okay, we evaluate d by dx of the integral from let me see, go back, from 5 to x to the third, from 5 to x to the third of the function 1 over t plus 2 with respect to t. So let's identify what we have. The function ft is 1 over t plus 2. And the function on the top there in the term of x, that's our, so this I use this as a u. So the u is x to the third. So set it aside, the du dx is 3x squared. From the prep work here, together with the one fundamental theorem of calculus part 1. So we write this as d by du, the integral 5 to the u, 1 over t plus 2 with respect to t. That's the first part of the chain rule, and multiply by the second part of the chain rule, which is the derivative of the inner function. And the first part, we apply the fundamental theorem of calculus part 1. The unknown, the u there, will be in place of the t. Then we get the function. It's going to be the function of the u instead of the function of the t, and multiply by du by dx, which is 3x squared. And what is the u? The u is x to the third. So that means we have 1 over u plus 2, or x to the third plus 2, multiplied by 3x squared. Put them together in one expression. So we have 3x squared divided by x to the third plus 2.